Hey, if you got yourself a voltmeter, you want to know how to use it better, save yourself some time, money, maybe save your life, you never know. Here's what I want you to do. Put the kids and the dogs outside, lock the door, go get yourself an adult beverage, sit down and watch this video. We'll be right back. Hey everybody, this is Charlie from Goose RV. Today I'd like to talk a little bit about typical consumer style voltmeters, or DVMs, and how to use them. They're a very valuable tool that can save you a lot of time and money. I'll try and keep it simple and focused on the tool and how it can be used around the home and your RV to make your life a little easier and help you troubleshoot problems when they arise, and we all know that they do arise. Now typically voltmeters are not simply voltmeters. They also provide other functions. There are ohm meters and there are ammeters. Ohm meters measure resistance, ammeters measure current in amps, right? But for this video, let's just call them DVMs. For the most part, all DVMs can measure resistance, current, voltage in AC and DC. AC, or alternating current, is what you find in your standard electrical outlet in your home or your RV. The term alternating is used because the voltage actually changes voltage 60 times a second. DC, or direct current, is a voltage form that is typically produced by a battery, is constant, unlike AC, usually a lower voltage like 12 or 24 volts. A flashlight battery, for instance, that's 1.5 volts. Car battery, truck battery, 12 volts typically. Now your RV has accessories that run on 12 volts, such as your lights, your water pump, usually your exhaust fan above your stove, ventilation fans throughout your RV, in the bathroom, etc. Also phone chargers, cigarette lighter plugs, USB plugs where you plug your cell phone in to charge. All that runs off of 12 volts. Now AC is typically what we use when your RV is plugged in to an electrical outlet at home, or if you're camping and you have full hookups, then they're providing AC power. Now DC power is an appliance that works directly from your battery when no AC is available, such as when you're boondocking or wilderness camping. Now AC and DC, these are two completely separate systems in your RV. Now of course, some would tell you that you can install an inverter in your RV, which you can, and that inverter takes your battery power and converts it to 110, 120 volts AC, so you can run your AC appliances like a hairdryer, microwave, air conditioners. Yeah, even your air conditioners. Won't run it for long, but these inverters will actually do the job. We'll talk about that in another video. Let's get back to voltmeters. Now they come in many shapes and sizes and been around for a very long time. So I'll tell you what, let's go out to the electronics shop and I'll show you a couple. And first of all, this here's an old military one. It's from the 60s. It's a basically VOM. You can do volts, ohms, and amps. And it's, you might well expect, built like a tank. It's got a top on it and it's got 4 big latches, all that kind of stuff too. So, but it still works great. And it's if it's got a needle, it's called an analog meter, by the way, instead of digital. Everything used to be analog, now everything's turning digital. Analog has its advantages, let me tell you. Okay, and this is an old Simpson VOM. I've had this for about 40 years, 35 years, something like that. It does the exact same functions. Again, analog meter. These used to be a couple $100 a piece. And this one here is a cheaper VOM. It's probably a $29 version or $39 version. We got here is a digital voltmeter, my first one. It's a real good one. It's a Fluke. That's the brand name. They make professional equipment for industry and commercial. This was probably $250 25 years ago. And this is your Walmart version. I believe that's where we got it. And you're looking at about a $15 meter there. But you know what? This, for general purposes, this does great. And here's a little snap-on. This is a digital voltmeter as well. It's all in one unit. And this being your positive probe and this being your negative probe. You can put an alligator clip on here, turn it on, go to town. Select your ranges, volt, ohms, and amps. Pretty cool. I have several voltmeters that I've acquired through the years. They've gone by different names such as VOMs, which is volt ohm meter, VTVM, which is vacuum tube voltmeters, simply multimeters, and most recently digital voltmeters, DVMs or DMMs for digital multimeters. Let's just call them meters. Okay, let's look at voltage measurements, since that's pretty much what you're going to be doing with your RV and your DVM. What I've got here is a very basic electrical circuit that represents most of the DC circuits in your motorhome. So we have the battery supplying the power. This is the device that wants the power. The wire supplies it, supplies a path, and the switch, when turned on, operates the system. It's a very complex system here, right? This is the exact same circuit you have in your RV, except instead of small battery like this, you have a much bigger battery, or batteries, and instead of a simple light bulb, you may have LED lights, water pump, your pop-out motors, a fan, or heaven forbid, mom's cell phone charger. What could possibly go wrong? Okay, turn on your digital voltmeter, set it to DC volts, which is direct current voltage. In some meters, you have to set the range for the voltage you might expect. For instance, if you're expecting 12 volts, you might want to set the meter to 20 volts, if that's the range it has. A lot of them are auto-ranging, you don't have to worry about that. Now, before we move on, you may already know this, but it's important, so I'm going to mention it. The negative side of the battery bank in most vehicles and all RVs is tied to the metal chassis or the frame of the RV, same as in a car or truck. So instead of the manufacturer having to run wires from the positive side of the battery and a second wire from the negative side of the battery to the fuse panel or your switch or your device, whatever you're trying to power, instead of doing that, the negative side is tied to the chassis, and the chassis actually supplies that return path, and that's also called the ground. The ground. So you have ground and a hot lead. Hot lead is the positive, ground is the chassis. Okay, so first of all, let's turn on your digital voltmeters, which I've done. Set it to DC volts, DCV. On some meters, you may have to set the range. If it's not auto-ranging, set it to the range higher, just one step higher than what voltage you expect to find. If you're looking for 12 volts, set it for 20 volts, like I've done. That's great. Remember, we're simulating here. This is your batteries in your coach or your RV. This is your device. These are all the wires. This is your switch that turns it on. And this wire is your chassis or return. So, for the sake of demonstration, I'm going to put my negative meter on the chassis, which is this path, the negative path going to the device. All devices in your motorhome are connected. One side of it is connected to ground. Okay. Now with the other one, let's say the switch is on. Okay. Okay, with the red lead, go right to the other battery, and you can see we have power on the meter, on the voltmeter. Now, let's say the switch is on, which it's really not, but for this demonstration, we're going to say the switch is on, and the light isn't working. So you got your meter, you're going one side to ground, one side to the negative wire, the positive wire on the device, and you still got nothing. You go, son of a gun, there's no power going to the device. Okay, you go back, make sure the switch is on. Let's say it is on. Now where are you going? You're going back to the fuse panel, because that's where the power comes from. In this case, you come back here, boom, there it is. You do have power. At this point, your suspect is between the fuse panel and the switch, very possibly the switch. Okay, what we're going to do now, we're going to go out to the motorhome and I'll show you the actual fuse panel, and we'll get away from this simulation for now.
The lights aren't working.
Which lights?
The main living room area.
The ceiling lights?
Yes.
All right. Okay, let's go find the fuse panel. I don't know about yours, but our fuse panel is about the most inconvenient location they could put it. It's at the foot of the bed, and I mean at the foot of the bed. It's underneath there. Okay. That's lovely. Okay, here's the fuse panel. Put the cover off. And there's our fuses. According to the label in the fuse panel cover, let's see here. 1, 2, 3, 4, 5, 6, 7, 8, 9 fuses. Number 8 says it's a 15 amp fuse and it's for the ceiling lights. So we're going to check that. Okay, from this angle you really can't see if anything is bad. I'll show you a way in a moment that you can visually check. Okay, let's get our voltmeter. Got our voltmeter, put it on DC volts, 20 volt scale. Now I'm going to take this negative lead. I'm going to find a piece of metal here, a substantial metal, like it's just out of frame, but what I'm using for ground, for the negative meter lead, there's a bed frame structure under here, and it's massive metal. It's tied to the chassis for sure. So I'm going to put the black lead on that, and then with the red lead I'm going to start checking these fuses from the bottom up. Okay, so one side of the fuse goes to the battery, and the other side of the fuse goes to the device. So let's check. I'm not sure which is the battery side on this, but let's just check them all. We're good. We're good. We're good. We're good. We're good. 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 Okay, the left side of the fuse in this particular case goes to the battery. So even if the fuse is bad, all of these sides are going to be hot, going to be 12 volts, okay, which I show you there. Now the right side goes to the device, and the fuse is in between the battery and the device. So let's just go here and check on the device side over here. That's good. Going up. That's good. That's position 6. 7 is good. 8. 8. The left side of 8 is good, but the right side is 0. Highly suspect. Looks like that fuse is the problem in this. It's a problem with the lights. Just for fun, let's go up and check the last one. It's hot on both sides. Okay, so definitely this fuse is bad. So we need to remove that fuse and replace it with one exactly like it. In this case, it's a 15 amp. We're going to replace it with a 15 amp. And they're color coded, as you can see, which helps select the proper rating. This one says 15 on it, but it's hard to read. Okay, so that fuse number 8 needs to come out and be replaced. So let's pull it out. Never use a pair of pliers or anything like that to pull these out. Plastic is very easy to grab onto. I don't know if you can see it or not. Let me see. You see the center part there? Probably a little out of focus. But the center part between the two tabs is supposed to be like a U or an S. In this case, it's supposed to be like a U. But you can see there's a break in it. It goes up and it's broken and it goes back down the other side. That's where that particular fuse melted at that point, which is what it's supposed to do if you're using too much current. So we're going to get rid of this one and replace it with this one. You can see this is a little different manufacturer, but that center piece is what's important. It's one continuous strip of metal. It's not broken in the middle like the other one was. So we're going to get that. We're going to put it back position number 8. If fumble fingers can get there. There we go. Now, just for fun, I'm going to take my meter. Light's a little bright. Take my meter, we'll try it again, put the black lead on the ground. We're going to check on the left side, which is the battery side. If I can see what I'm doing, there we go. There's battery. On the right side, which was dead before, now it's hot. So that means we got battery going to the light switch. So let's go in the living room and see if it worked. Okay, let's take a walk. Turn off that air conditioner so you can hear me. Alright, here we go. This is the big trial. Put that on, and lo and behold. Now you might ask yourself why I didn't check the bulb before I checked the fuse. The reason being, that particular light switch operates 1, 2, 3, 4 different lights. So the possibility of all 4 lights being burned out at once is pretty impossible. So went straight to the fuse panel. We replaced the fuse that cost about 50 cents and we're back in business. Okay, so one thing to remember, we had a blown fuse in the motorhome. The lights weren't working. We had a blown fuse. We replaced the fuse. The lights were then restored. Fuses don't typically fail by themselves. I have seen it happen, but typically it's a safety valve. It's an item that is a weak link in the chain, and if a fuse blows, it means something else is wrong that caused excessive current draw and blew the fuse. Fuse is considered blown or open if it's bad, like the one we saw in the motorhome. So simply replacing the fuse may not be the primary problem. Carefully replace the fuse and see what happens. If it blows again, you have a problem elsewhere that is causing excessive current to flow, such as a bad fan, a bad pump, a shorted winding in a motor somewhere, or other problem. It may be time for you to get additional help for further troubleshooting. Whatever you do, always replace that fuse with another one of the exact same rating. These things are rated for that particular circuit. In this case, it was a 15 amp fuse because they know that during normal operation, that circuit which operated those 4 lights would never draw 15 amps. But maybe with incandescent bulbs, they would draw a fraction of that. But if something goes wrong, 15 amp fuse is going to blow before any wire melts or anything bad happens. Yeah, you don't want to replace a fuse with a bigger fuse like a 20 amp or a 30 amp. Heaven forbid. Never ever do that. Earlier I mentioned the resistance or ohms reading ability of your typical meter. I'll be very brief here. Okay, at a very basic level here, I'm going to take a piece of wire, actually this here clip of this alligator clip with a piece of wire. It's probably about 18 inches long. I've got it coiled up to save space and so we can have it on the video frame. Of course, a piece of wire like that, it doesn't matter if it's 6 inches long or 600 feet long for the demonstration I'm going to show you. Take your meter, put it in the ohms reading, ohms position. In my particular case, ohms, keep these leads in the same position. Keep your range in the same position for now. And we're going to clip this piece of wire and turn this around so you can see. There we go. Anyway, clip one end of the wire to the black lead and one end to the red lead. Now, something to remember on measuring resistance, polarity means nothing. We're just checking resistance or continuity. In this case, we're checking continuity of the electrical path of this wire. Okay, so watch the meter. Right now it's reading, actually it's an overload condition. It's infinite. I'm going to connect this and you're going to see that drop to near zero. There you go. Okay, so if you're checking a fuse, I just happen to have a bad fuse right here. That'd be a good demonstration. Checking a fuse or a light bulb or something like a temperature sensor that should have continuity or a particular resistance. I'm going to put this on the other lead of the fuse and look at that. It's still open. Infinite means there's no current flow. There's a break in this connection between here and here. Where in a fuse, of course, it's supposed to have a connection. Fuse is bad. We proved it about 6 times now. So let's clamp that back on there. Okay, again, I've got the wire connected. In this case, it's a short piece of wire. Resistance is basically 0. It's a very small amount of ohms. Very small resistance, I should say. Way less than 1 ohm. And maybe your meter would basically reach 0, pretty much as mine is now. If you change the scale, you might get a very, very small reading, but essentially it's 0. Now, if you were to leave the meter connected and cut this test piece of wire in half, breaking the connection, the meter would immediately show infinite resistance because there's no longer an electrical connection in the wire. Click. See that? Current flow would be impossible through a broken connection, and anything relying on that electrical connection would fail to operate. Now, this is the same principle of a fuse in your car, truck, or RV. Has an assortment of fuses built into the vehicle. Their job is to give a path for electrical current to pass through them and allow your appliance to operate, but at the same time, the fuse is designed to be the weak link in that circuit and open up or blow, like cutting the wire, if excessive current flows in that circuit, stopping all electrical flow in that circuit. It's a safety valve. Now, if you did not have a fuse in each circuit, the only limit to excessive current flow in that particular circuit would be the wire itself. And in a short circuit situation, you could possibly and probably have a fire if you didn't have a fuse. Fuses are safety devices. This is why you'll always replace a bad or blown fuse with one of the same rating. Now, I've said that probably 4 times during the presentation, but it's extremely important. Okay, this is a very important final chapter to this video. I apologize for the length of this video, but what I have to say is important and it can save you a lot of money, possibly your own safety of yours and your family. Okay, in the old days, when I was very young, as you could well imagine, houses had fuses instead of circuit breakers. And a fuse would blow because homeowners were trying to draw excessive power from their house circuit beyond the safety limits of the wiring. Maybe they plugged in a couple of heaters and some lights and who knows what, refrigerator, and all of a sudden they blew a fuse. Now, an extremely dangerous but unfortunately common practice was that the inept homeowner would replace the bad fuse with, yep, a penny. He would unscrew the bad fuse and in its place cram a penny in the socket. Maybe you've heard the phrase penny in the fuse box. Well, when this happened, all safety measures in that electrical system are gone. If the homeowner continued to use excessive power, the wiring in the house would heat up and it would invariably catch fire. This terrible practice and others like it gave our fire department and others like us across the country, around the world, lots to do, unfortunately. Now, I saw many poor practices like this during my 24 years in the fire department, and it usually resulted in partial or total loss of people's homes, and sometimes, sadly, a loss of life. So much for a lucky penny. Maybe those guys should have had some spare fuses on hand, right? Have you ever heard of this happening? Let me know in the comments below. I know this houses haven't had fuses in a long time, but there still are some out there. Houses that were built in the 40s or earlier use fuse boxes instead of a circuit breaker box. Okay, one final thing before we close, and this is important if you value your tools like I do. If your DVM or voltmeter is still set to the resistance scale after you check for continuity or resistance, make sure as soon as you're done you take it out of that resistance mode by going back to a voltage mode. The reason for that is if you try and check voltage or current especially while it's still in resistance mode, you could damage your meter. A lot of the better meters have a fuse, an internal fuse that protects the workings, but trust me, you don't want to take a chance. Some of these guys are very expensive. It's just good practice to get in the habit of keeping the DVM setting to a voltage reading, voltage scale when you're done using it, and then turn it off. Like so, and like so. Okay, I hope you got something from our video today. Again, I apologize for the length, but there were some things you needed to know before we started talking about working on your electrical system. If you did get something from the video, please give us a thumbs up down below and subscribe to our channel, Iron Goose RV, where we share repairs, mods, and our motorhome exploration of this great country. Thank you. Have a good day.